Welcome back to Basic Mathematics. In this video, we're talking about multiplying decimal numbers. The idea of multiplication with decimal numbers, unfortunately, is a little bit more complicated than the process of adding and subtracting. And the reason for that is that the place values are hiding a whole bunch of multiplying and dividing by 10. So let me get my head out of the way and let's dive right into an example here. Let's take a look at 3.5 times 4.2. If you think about this in expanded notation, which is not something we've used all that much, the 3 is in the ones place, and the 5 is in the tenths place, which means we want to divide by 10. And then we have the 4 in the ones place and the 2 in the tenths place, which again means that we want to divide by 10. And so when we multiply things together here, we have a divide by 10 once from the first number and again from the second number, which would mean divide by 1 twice, or the hundredths place should be what we end up with in our result. And so that's what we're going to end up with, and that's how we're going to think about things. In order to actually perform the multiplication, if we want to do it by hand, we're going to set up our columns. We're going to have 35 and 42. Yes, I'm completely ignoring the decimal point as I write these numbers down. You can include it if you want to, but it's not strictly necessary. It doesn't change anything to have that decimal point in the multiplication, so I usually leave it off. And I multiply 35 times 42 the same way I would if it was just multiply some whole numbers together as our instructions. 2 times 5 is 10, write the 0, carry the 1. 2 times 3 is 6, plus 1 is 7. Next line, move over one place. 4 times 5 is 20, write the 0, carry the 2. 4 times 3 is 12, plus 2 is 14. Add everything together, 1470. And now I said, when I expanded this out, that we were going to need the hundredths place, and that is what we're going to need. But a more straightforward way of thinking about it, I've got one digit after the decimal point in this number. I've got another digit after the decimal point in that number. All told, that's 2 digits after the decimal point. So I'm going to come in so that there are 2 digits after the decimal point. In this case, it will be the 7 and the 0, and write down that my result is 14.70. One more thing that you can think about to justify this response. Whenever you're performing multiplication, you can always round to get an approximation of what the result would be. So in this particular problem, we're looking at 3.5, which is about 4, right? Rounding to the nearest whole number, you would round that up to 4. We've got 4.2, which is also about 4. 4 times 4 is 16. If I took 14.70 and I rounded to the nearest whole number, I would get 15, which is not exactly 16, but pretty close. So if you think about what the numbers would be if you rounded them, and make sure that the result you end up with is relatively near, then it's a good sign that you're in the right place. If you were well off, right, if I multiply in rounding and get 16, and then I look at my result and I got 147, that is a significantly different number. Likewise, 1.5 is a significantly different number. 12, 16, 25, those are all about the same size of number. They have the same number of digits before the decimal point. And so that's what we're looking for here. All right, let's get this problem off of the screen so that we can take a look at one more example, a little bit messier as far as our numbers go. .76 times 21.5. All right, using my rounding trick, 3.76 is somewhere in the ballpark of 4, and 21.5 is somewhere in the ballpark of 22. And we can multiply 4 times 22 in our heads. It's going to come out as 88. Right? When I multiply this, 3.76 times 21.5, I'm not expecting to get exactly 28. In fact, since I rounded up in both cases, I know that the result I end up with should be smaller than 88, but that gives us a good ballpark of what we should be looking for. If it's drastically bigger or drastically smaller, we know something went wrong. But let's write down those digits. 3, 7, 6, and 2, 1, 5. Again, you can write the decimal point in if you want to, but it doesn't actually change anything, so I find it's just as well to leave it off. And you multiply out column by column. 5 times 6 is 30. Write the 0, carry the 3. 5 times 7 is 35, plus 3 is 38. Write the 8, carry the 3. 5 times 3 is 15, plus 3 is 18. Nothing else to go, so I just write down the 18. Come down to the next line, move over one space. 1 times 376, that's easy mode, 376. Come down to the next line, move over 2 spaces this time, and multiply 2 times 376. 2 times 6 is 12, write the 2, carry the 1. 2 times 7 is 14, plus 1 is 15, write the 5 and carry the 1. 2 times 3 is 6, plus 1 is 7. Add up column by column. We've got 0, 8 and 6 is 14, write the 4, carry the 1. 1 and 8 is 9, plus 6, 1 and 8 is 9, plus 7 is 16, plus 2 is 18. Write the 8, carry the 1. 1 and 1 is 2, 2 and 3 is 5, 5 and 5 is 10. Write the 0, carry the 1. 1 and 7 is 8. 80840. We know that we wanted to have a result that was somewhere near 88. So putting the decimal point there, we can think of just from that is the right place to put it. But again, the technically correct way of thinking about this is that there are 2 digits after the decimal point in this number and 1 digit after the decimal point in that number. So we need 1, 2, 3 digits after the decimal point in our result, 80.840. The last thing that I want to talk about in this video is the trailing 0 on our decimal number. I mentioned in our video on adding and subtracting decimals that technically speaking, you don't need that number. You can leave it off and everything will still work fine. 80.84 is numerically the same value. Depending on where you are moving on from this course, what you are studying, why you are going to use math in the places that you use math in your careers, there could be a distinction between the value of 80.840 or 80.84. For our purposes this semester, that is well beyond anything I want to care about. I will accept either of those values equally. In D2L, sometimes you'll see some problems, and in my math lab, sometimes you'll see some problems with how numbers are accepted and how they expect you to round things. One thing to always pay attention to is instructions will often ask you to round. If the instructions say round to the nearest hundredth or round to the nearest thousandth, make sure that you pay attention to those instructions and round your result appropriately. That is a very common place to miss points that really you should not have a trouble with. It's not a difficult thing to do. It's just a matter of paying attention. While I'm on the subject of zeros, I guess I should also mention that there are two schools of thought for numbers smaller than 1. Some people will just put in a decimal point and then start putting in numbers after it, 0.736. Other people insist that there should be at least a 0 in front of the number if the number is smaller than 1. I count myself among the second camp, but again, for our purposes in this course, it's not going to be something that we're going to worry that much about. I just want you to be aware that there are two schools of thought, and some people are very vigorous in their defense of their preferred method. If you have me in a future course, you might see me become vigorous in my defense of my method myself, but for our purposes right now, I'm not going to worry about which one you choose. All right, take some time practicing multiplying decimal numbers, and I'll see you in the next video.